Hello everyone, I am Atul Kulkarni. The objective of this screencast is to discuss one basic example of Fourier series and discuss about Gibbs phenomena. So let us revisit the basics that we know already about the Fourier series. This one is the Fourier series equation. And here what we know about Fourier series is, with the help of Fourier series, we are able to decompose any complex periodic signal into sum of sines and cosines. So if we assume this is a periodic function, then it can be represented in terms of this sines and cosines. This is what Fourier series is. And the Fourier series components A0 coefficients A0, An and Bn, these also we need to compute. And how to compute A0? A0 can be computed like this using this formula. An can be computed using this formula, and Bn can be computed using this formula. This is all about Fourier series that we know from the last screencast. Now let us take one example here. Now here one square wave is shown. And what is the question? Find the Fourier series of the following periodic function. Is this signal periodic? Yes. This is a periodic square wave. And the same periodic function can be written mathematically as if this signal is named as f theta, then f theta is equal to a for 0 to pi duration. For 0 to pi the value is a, whereas for pi to 2 pi the value is minus a, and this is one cycle, and again next cycle repeats. The period of this cycle is 2 pi. That is what mentioned here. F of theta plus 2 phi is equal to f of theta. As we know the basic formula for the periodic function, that is f of t plus capital T is equal to f of t, where capital T is nothing but the period of the periodic signal. So same here utilized to indicate that this signal is a periodic one. Now why we discussed whether this signal is periodic or not, aperiodic? Because we know that Fourier series is only applicable for the periodic signal, and we came to know that this signal is periodic now. Now what is our aim? Our aim is to decompose this complex signal in terms of sines and cosines. So what is Fourier series equation? That we have already discussed. This is Fourier series equation. Means we have to decompose that square signal in terms of this sines and cosines. So the first thing is we need to find out the value of A0. A0 is equal to 1 upon 2 pi integration over 0 to 2 pi f of theta d theta. And what is f of theta? F of theta is a for the period 0 to pi, and f of theta is minus a for the period pi to 2 pi. And if we put these values here, a and minus a, having the period given here 0 to pi and pi to 2 pi, then if you solve this further, then we'll get value of A0 is 0. Okay. Now what is our next step? We have to find out all three coefficients, all three Fourier coefficients. A0 we have calculated, that is now 0. Now go for An. An is equal to, as we have this basic equation, An is equal to 1 upon pi minus pi to pi f of theta cos n theta d theta for all n. Okay. So here solving this integral f of theta, as we know that it is a for 0 to pi and minus a for pi to 2 pi. Further solving this equation also leads to a final value 0. Means so for now we have computed two Fourier coefficients A0 and An. And now if you look at this equation, then this is first coefficient, this is another one, and now we have to find out the coefficient Bn. So let's find out the coefficient for Bn. As from the basic formula to find out the coefficient Bn, 1 upon pi 0 to 2 pi f of theta sin n theta d theta. Now f theta we already know that its value is a for 0 to pi, and pi to 2 pi its value is minus a. If you solve this equation further, we'll get this equation. Now the beauty of this equation here, Bn is equal to this equation we got, and if we put value of n as an odd value 1357, then Bn becomes equal to 4a upon n pi. And if you put the value of n as 2, 4, 6, 8, that is even value, then this bn value leads to 0. So far now we tried to find out three important Fourier coefficients, an, bn and a0, where we come to know that for this particular signal, the value of a0 is 0, value of an is 0, and value of bn is either 4a upon n pi or 0, depending on n is odd or n is even. So if we put this value in the main Fourier series equation, then a0 term and an term, these two terms becomes 0. Now see this, a0 and n, these two terms become 0, only this term we need to compute further. And we already know that bn is equal to 4a upon n pi. And if we put this value of bn here, and if we further expand this equation for n is equal to 1 to infinity, then 4a upon n pi, n is nothing but 1 initially, 1, then 3, then 5, then 7, because for the even values of n, this bn leads to 0, hence the total term becomes 0 for even values of bn. Hence this is only for the odd values, and this is expanded further, and this equation is further solved in this step to get 4a upon pi as a common factor from these various terms, and this equation leads to now this one. And after this, if you plot this function now see here how many sinusoids are there? Infinite sinusoids are there, but because of the practical limitations we need to truncate it. And if we consider only 5 terms, then how the plot looks like. So if we consider 5 terms only, then that plot will looks like this. If you consider 9 terms, then plot becomes like this. If you consider 13 terms, then plot looks like this. Means more the terms, more the approximate your plotted signal becomes equal to your original function. This is what Fourier decomposition of a given signal we have done now. But here what we can observe, if we observe all these 3 plots, then we observe that after looking all these plots, we observe that at the edges where discontinuity occurs, oscillations are observed at the edges, and these oscillations occurred at the edges is referred as ringing effect, and this ringing effect is also called as Gibbs phenomena. And these oscillations do not disappear even when the total number of terms used very large. Now here how many terms we have used? 13. If we go on further increasing the terms, still we'll observe this ringing effect. That is what it means. And remember that the Fourier series is an infinite series with indefinite number of terms. Since we cannot calculate all the infinite number of terms practically, we have to stop at some point. And this truncation of number of decomposed terms leads to Gibbs phenomena. Thank you.